Welcome back, Science 10. This is the next lab in the reaction rates unit. So far you've looked at altering temperature and seeing how that affects rate. You've altered concentration of reactants and seen how that affects rate. So now we look at changing the surface area of reactants and seeing how that alters the rate. So this lab is based on the labs on pages 268 of 269 and 269 of the textbook. And the purpose, how does surface area affect the rate of a reaction? So your prediction here will be, I believe that as surface area increases, that the rate of reaction either increases, decreases, stays the same. We'll look through the whole lab and then you can come back and answer that question. Make a prediction as to how you think surface area. Okay? So first of all, surface area. Basically, you're looking at how much of the outside part of the reactant is exposed to air or water or whatever the reaction medium is. So surface area, how much of an object's outside surface is exposed. Okay, so that is how. That is what surface area is, and how it's determined is by simply calculating the outside surface that's exposed. So this lab, once again, we're going to be using Alka-Seltzer tablets, beaker, water, of course. Procedure, it's in the textbook there, but we'll also go through it on this handout here. Goggles are likely a good idea too. Two parts for this. We're going to be looking at a calculating part that we're going to do together. Part one, calculations to determine how surface area is affected when a solid is broken up. And then part two is the actual testing that you'll do in the lab. 3 different tests will be done with Alka-Seltzer tablets in 200 mils of water. So a 250 milliliter beaker with 200 mils of water, similar to what you've done previously. And the test you're going to be doing, you're going to be using half tablets. So the first test will be just using a complete half tablet, seeing how long it takes. Test 2, taking another half tablet but breaking it into a few chunks. And then the last test will be using a half tablet but crushing it into very small pieces, powdering it basically. Okay, and of course we're reacting it in 200 mils of water. So those are the 3 tests you're going to be doing. Okay, the next page, if we look at how surface area is determined when we break something up. So first of all, let's assume we have a cube here that's 2 by 2 by 2. So the length of each of these individual cubes here, and I've kind of drawn this bigger, I know, but kind of envision this as one of these cubes right here is 1 by 1 by 1. Okay? So of course the surface area of one of the large 2 by 2 cube, let's assume it's 2 centimeters by 2 centimeters. So, of course, you remember from math class, area of a rectangle is length times width. So 2 centimeters by 2 centimeters gives you 4 square centimeters. And, of course, how many faces do you have on this cube that are exposed to the air? 1, 2, 3 behind, 4 behind, 5 above, and 6 below. So there's a total of 6 faces there, 6 sides, so 4 square centimeters times 6 sides. So all of the area that's exposed to air, kind of envision it like a Rubik's Cube, 24 square centimeters. Okay, so that is the total surface area. If we were to take this cube and roll it like a dice, there would be 24 square centimeters of area that we could see. Okay? Now, if we look at if we were to break this up into 1, 2, 3, 4, 5, 6, 7, 8. 8 of these little cubes make up the big cube. And each area of the little ones is 1 by 1. So area equals length times width. 1 by 1 is 1 square centimeter. And of course this little cube has 6 sides as well. So 1 square centimeter times 6 sides is 6 centimeters squared. And since this big cube is made up of 1, 2, 3, 4, 5, 6, 7, 8, if we multiply that by 8, we would have 48 square centimeters. So breaking this up makes more surface area. So to increase the surface area of something, You break it up into smaller pieces. Just like back here what we're doing with the lab. Only this part of the Alka-Seltzer tablet is exposed. You break it up, then you'll have these edges that are exposed, and if you powder it, every little fine particle is exposed to the air and the water. So what we're doing here by breaking this up is increasing the surface area, increasing how much area is exposed to the water or air. Okay, so yeah, I mentioned it here. If we cut up the cube, more surface area is exposed. Increase surface area by cutting up into smaller pieces. Now, part 2, I've changed it a little bit here, so we're not going to be taking the mass of the tablets, etc. We're just simply going to be timing it, and of course, we use time to kind of get an indication as to how the rate is affected. If it's a really short time, that means fast rate. It happened really, really fast. Or if the time is long, it was a really long rate. It took a really long time for time. Therefore, the rate is small. So here we just put here a whole half tablet, time taken. So that's the first part of the lab, and we're just looking at this. The time for the whole half tablet to react. Okay? And then when we have the tablet in chunks, around 3 to 5 chunks, how long does that take? So basically this part here, when we have that half tablet broken into a few chunks. And then lastly, how long does it take the powdered tablet to react? So just cross out that material there that we're not going to need. It's kind of messy, I apologize for that. I didn't have a chance to remake this. So just make these little changes here, and then you'll be good to go. Okay, once we have those times done, of course the conclusion, what were you going to do? The purpose was to What did you think would happen? It was thought that. So whatever you said in your hypothesis. And then lastly, what did happen? Was your prediction right? And then again, yeah, cross out these part 1s and part 2s here. We're not going to worry about that. Then some follow-up questions. Dealing with surface area. So some things in real life can be explained by using this idea. So if you have 2 logs, if you have a log and if you have another log that's cut into really, really small twigs, which burns quicker, the log or the log that's broken up into small twigs? Also, if you have a lump of coal versus that same lump of coal ground up into really fine pieces, a lump of coal, of course, in a barbecue reacts very slowly when exposed to flame, but if you had coal dust and threw it on fire, it would actually explode. Why? Fruit. Perfect example of this is an apple. When you take an apple and cut up into small pieces, leave it on the counter, you can see it browns really, really quickly. Why is that? And I guess that's the last question there. This is the next assignment. So there we go. There's your introduction to the surface area lab. Good luck.